I want you to try a thought experiment with me.
Okay, I'm listening.
Imagine I handed you a copper chisel, so basically a soft piece of metal, and a stone hammer.
Right, Bronze Age tools.
Exactly. And I told you, okay, go into the desert, cut 2.3 million blocks of limestone that weigh as much as an elephant each, and stack them up.
A pretty big ask already.
But there's a catch. You can't just stack them. You have to stack them so precisely that the entire structure aligns with the compass to within a fraction of a degree.
Okay.
Oh, and one more thing. You need to scale the whole thing so that it mathematically encodes the exact dimensions of the Earth.
Which, just to be clear, implies you actually know the exact dimensions of the Earth.
Right. Which, if we're talking about 4,500 years ago, you definitely shouldn't know.
Not a chance.
If I told you that story, you'd say it was impossible. You'd say I was describing, I don't know, a sci-fi movie. But today, we are diving into a stack of research that suggests this is exactly what happened on the Giza Plateau.
It really is one of those topics that, once you start pulling at the threads, the whole sweater of standard history starts to unravel a bit.
It really does.
And I know people hear pyramids and they think aliens or magic, but what we are looking at today isn't that. It's data.
Right.
It's math, it's geology, and it's astronomy. And the measurements, the hard numbers found in the structure itself, are forcing us to ask a very uncomfortable question. Did the ancient Egyptians actually build the Great Pyramid?
Or did they inherit it from someone else?
That's the question.
And that is the mission for this deep dive. We're going to walk through the source material, which includes some pretty shocking analysis of the Great Pyramid's geometry and history.
We're talking impossible engineering, a mathematical code.
And geological evidence that suggests these things might be thousands of years older than our history books admit. So, yeah, buckle up.
It's going to be a wild ride. But before we get to the really mind-bending stuff, we have to ground ourselves in what we think we know.
The standard story.
The standard story.
Right. The textbook version, I remember this from school. The Great Pyramid was built around 2500 BC, 4th Dynasty, Pharaoh Khufu. And the main point was, it's a tomb.
A really, really big tomb.
Exactly. A massive mausoleum for a king.
But here is the first crack in the foundation, and the materials we're looking at today highlight this immediately. If it's a tomb,
Here's the body.
where is the body?
See, this always confused me. I watched all the movies, the documentaries. I thought we had bodies.
We do. We have bodies in the Valley of the Kings. We have mummies in other places. But in the Great Pyramid of Giza,
Nothing.
despite centuries of, looting, exploration, and modern archaeology, zero. No mummy of a pharaoh has ever been found inside.
Not even a bone fragment.
Nothing that conclusively links a body to that structure. And skeptics will say, well, grave robbers got there first.
Which is possible, I guess.
It is. But we've found sarcophagi that appeared sealed and, when opened, empty. It just raises the question, if the primary purpose was to house a corpse, why does the building seem designed for something else entirely?
And when you say designed, we need to talk about the sheer scale of this thing, because big doesn't really do it justice.
Yeah.
The research breaks down the numbers, and it's actually terrifying.
2.3 million stone blocks,
2.3 million.
ranging from 2 to maybe even 50 tons each.
Okay, let's do some napkin math on that, because the source material mentions this, and I checked it. If they built this thing in 20 years, which is the standard estimate for Khufu's reign,
They would have to quarry, transport, shape, and place one massive block every few minutes.
every few minutes,
24 hours a day, 7 days a week, for 20 straight years.
without a single crane,
Yeah.
without a wheel. Because remember, they didn't technically have the wheel for heavy lifting yet. Just copper chisels and hemp ropes.
Logistically, does that even make sense to you?
It's staggering.
It's incredibly difficult to explain. I mean, try moving a refrigerator up a flight of stairs with 3 friends. Now imagine that refrigerator weighs 10 tons,
Right.
and you have to lift it 400 feet in the air and place it so perfectly that you can't fit a razor blade between the stones.
That's the part that gets me, the precision. I hired a contractor to redo my patio last year.
Oh no.
Flat ground, modern tools, and he was off by an inch on a 10-foot slab. The water pools in the corner. Drives me nuts. But the Great Pyramid.
The research highlights this specifically. The base of the pyramid covers 13 acres.
13 acres! That's a huge area.
And yet the level of the foundation varies by less than 0.75 inches across the entire thing.
Less than an inch.
That is laser leveling precision. In the construction world today, that is considered high-end engineering.
And they did it how?
With water trenches and sighting rods, supposedly. It's bordering on the miraculous. And then there's the alignment.
The compass thing.
The eastern and western walls are aligned to true north. And we need to distinguish here, not magnetic north, which moves around because of the Earth's core.
True north. The geometric top of the planet.
Exactly.
And how close are they?
Within 3/60ths of a degree. That is the accuracy of a modern maritime compass. To lay out a building that large, with that kind of orientation, implies an understanding of astronomy and surveying that we just don't credit to the Bronze Age.
Okay, so we've established that physically this building shouldn't exist. It's too big, too heavy, and way too precise for the tools they supposedly had.
Right.
But here is where the deep dive gets really deep. And this is the part of the research that honestly made me put my coffee down.
The math.
The math.
This is where we move from impressive engineering to impossible knowledge.
So the source draws a connection between the pyramid and the dimensions of the Earth. But it starts with a number. A very specific number derived from the equinox.
Right, so think about the equinox. It's the 2 days of the year, March 21st and September 22nd, where day and night are perfectly equal.
12 hours a day, 12 hours of night.
Exactly. Now, in ancient geometry and timekeeping, the sexagesimal system base, 60 was everything. 60 seconds, 60 minutes.
Okay, I'm with you.
So if you take that 12 hours of the equinox and you calculate how many seconds that is,
Yeah.
what do you get?
So 12 times 60 times 60. The source says it's 43,200.
43,200. It seems like a random number, right? Just a chunk of time.
It sounds totally arbitrary to me.
We'll keep that number in your head. 43,200. Because if the Great Pyramid is a scale model of the Earth, that number is the scale.
Okay. Walk us through this.
If you take the original height of the Great Pyramid, which we can calculate based on the slope, and you multiply it by 43,200,
You get?
you get 6,333 kilometers.
And 6,333 kilometers is?
It is the Earth's polar radius, the distance from the center of the Earth to the North Pole, with an accuracy of 99.6%.
Okay. That's weird. But it could be a fluke, right? You multiply enough big numbers, you eventually hit a target.
That's what a skeptic would say.
Yeah.
And I'd agree, if it stopped there.
But it doesn't.
But it doesn't. Now, take the perimeter of the base of the pyramid, the distance you'd walk if you did a lap around it.
Right.
Multiply that by the same number, 43,200, you get 39,840 kilometers.
Which is? Don't tell me.
The Earth's equatorial circumference, with 99.3% accuracy.
Okay, hold on. So you're telling me that the height scales to the radius and the perimeter scales to the circumference using the same multiplier.
The same exact multiplier derived from the time of the Earth's rotation.
That feels like it can't be a coincidence. To get a 99% match on both dimensions, it's a 1 to 43,200 scale model of the Northern Hemisphere.
The odds of that happening by accident are, well, astronomical. It implies that the builders didn't just know the Earth was a sphere, which, again, was knowledge supposed to be thousands of years away.
They knew the exact size of that sphere.
Exactly. They knew the flattening at the poles, they knew the bulge at the equator, and they encoded it into stone.
It's like hiding the password to the planet in a pile of rocks. But if they knew all that, they must have been tracking the stars with incredible accuracy.
They were obsessed with the stars. And this brings us to one of the most controversial but visually striking theories in the source material.
The Orion correlation.
The Orion correlation.
This is the Graham Hancock theory, right? We should probably explain who he is. He's a bit of a lightning rod.
He is. Graham Hancock is a journalist, an author, who has spent decades arguing that human history is older and more complex than we think.
He gets dismissed a lot by mainstream academics.
He does. But his observation about the Giza pyramids is hard to ignore.
The belt stars.
Exactly. Look at the constellation Orion. You have the 3 stars of the belt. 2 are bright and in a straight line. The third one is slightly dimmer and offset to the left.
Okay.
Now look at the Giza plateau from above. You have 2 massive pyramids, Khufu and Khafre, perfectly aligned, and then the third one, Menkaure, is much smaller and offset to the left.
The pattern on the ground matches the pattern in the sky.
It's a dead ringer.
I've seen the overlay. It's pretty undeniable. It looks like a map.
It does, but there's a problem, a big one.
Lay it on me.
If you look at the sky tonight, the angle of Orion's belt doesn't match the angle of the pyramids perfectly.
It's tilted wrong.
And if you go back to 2500 BC, when the pharaohs were building, it was still wrong.
So the theory is bust.
Well, this is where astronomy saves the day, or complicates it, depending on your view. We have to talk about precession.
Precession. That's the wobble, right?
Right. Think of the Earth like a spinning top. As it spins, it wobbles very, very slowly. One full wobble takes about 26,000 years.
And this changes how the stars look from Earth.
It changes their position in the sky over long periods of time. So the sky today looks different than the sky 5,000 years ago.
Completely different angles.
So using computer models, we can rewind the sky. If you roll the clock back, looking for the moment when the stars of Orion's belt line up perfectly with the pyramids on the ground, you find it.
And when is it?
Roughly 10,500 BC. Some models say 11,400 BC, somewhere in that ballpark.
Whoa. Wait, 10,500 DC? That's 13,000 years ago.
It is.
That is nearly 8,000 years before the Pharaoh Khufu was even born.
Precisely. And that is the terrifying implication. The astronomy suggests the site plan, the blueprint for where these things sit, dates back to the end of the last ice age.
But history tells us we were hunter-gatherers then. We were chasing mammoths with spears, not building 50-story stone monuments.
That is the conflict. The stars say one thing, the history books say another. But here is the kicker.
What's that?
The stars aren't the only thing pointing to that ancient date. The ground itself, the geology agrees with the stars.
And this is where we talk about the Sphinx, because usually we lump the Sphinx and the pyramids together.
But the Sphinx is a different beast entirely. It is carved directly out of the bedrock.
Which means it's weathered differently.
Exactly. And the source material leans heavily on the work of Professor Robert Schoch. Now, unlike Hancock, Schoch is a mainstream geologist from Boston University.
So he's not some fringe guy.
Not at all. He went to Giza expecting to disprove these wild theories.
And what did he find?
He looked at the enclosure walls around the Sphinx, the limestone cliffs, and he found deep vertical fissures.
Vertical?
Imagine running water down a mud bank. You get these vertical channels.
Water erosion.
Rain erosion.
Yeah.
Heavy, prolonged rainfall.
But it's the Sahara Desert. It hasn't rained like that there in...
Forever.
Exactly. Erosion from wind and sand, which is what you'd expect in a desert, looks like layers, horizontal scraping. The Sphinx has vertical water damage.
So to get that kind of erosion.
To find a climate in Egypt that was wet enough to do that kind of damage to solid rock, you have to go back to the pluvial period.
Which was when?
The end of the last ice age. Around 10,000 BC to 5,000 BC, before the Sahara dried up.
So connect the dots for me here. The stars align with the pyramids around 10,500 BC.
Right.
And the rain erosion on the Sphinx requires a climate from around 10,000 BC or older.
Both independent lines of evidence astronomy and geology triangulate on the exact same window of time.
A time thousands of years before the dynastic Egyptians were supposed to be there.
It's heavy stuff.
Because if the Sphinx was there to get rained on in 10,000 BC, then someone built it before 10,000 BC. And if the pyramids are a map of that same era, then the pharaohs didn't build this complex.
Well, he lived into it.
They found it. This is the inheritance theory. And it actually solves a lot of problems. For example, why is the Great Pyramid the best one?
What do you mean by that?
Usually technology improves. You build a Model T, then the Mustang, then the Ferrari.
Right.
But in Egypt, the Great Pyramid is the Ferrari. The pyramids built later, hundreds of years later, are smaller, crappier, and crumbling. Many are just piles of rubble now.
So they got worse at it over time.
Which makes no sense if they invented the technology.
Yeah.
But it makes perfect sense if they inherited the Great Pyramid from a lost civilization and then spent centuries trying to copy it.
But they couldn't quite figure out the lost tech.
They couldn't. It's like if we found a nuclear power plant from previous civilization, didn't know what it was, and tried to build a copy of it out of bricks, it might look similar, but it won't work.
That's a great analogy.
And the source material points out one final damning piece of evidence for this inheritance idea.
Which is?
The silence.
The lack of records.
We know what the Egyptians ate. We know how they brewed beer. We have receipts for grain. We have records of wars. But for the construction of the single greatest engineering feat of the ancient world.
Nothing.
Silence. No blueprints. No instruction manual.
You'd think the architect would want credit. I, Bob, built the big one.
Unless they didn't build it. Unless they just cleared the sand away from something that was already there.
And that leads to the really big question, the terrifying truth the source material alluded to. If the Egyptians didn't build them, and if we were just hunter-gatherers, then who did?
That is the mystery of the lost civilization.
Yeah.
The idea is that around the end of the Ice Age, 12,000 years ago, there was a civilization on Earth that was advanced.
Advanced how?
Maybe not with iPhones, but with a different kind of tech. Mapping, masonry, astronomy. And then something happened.
The Ice Age ended.
Violently. Sea levels rose 400 feet. Continents were reshaped. If a civilization existed on coastlines, they would have been wiped off the map.
And all that would remain.
All that would remain are the big, heavy stone monuments in the highlands, like Giza.
It changes the whole story of humanity. We aren't on a straight line from cavemen to astronauts. We might be a restart.
And we might be version 2.0
Yeah.
of civilization, living in the ruins of version 1.0 and not even realizing it.
It's a lot to process. But when you look at the 43,200 number, the precision that rivals lasers, the water damage in a desert, it's hard to just shrug and say, coincidence?
Coincidence is a lazy explanation for data this precise.
Huh.
The Great Pyramid is a message we're just finally learning how to read it.
So here's the thought I want to leave you with today, and it's a provocative one. If there was a civilization 12,000 years ago that knew the size of the Earth and mapped the stars and built mountains out of stone, and then they vanished, what else did they know?
Did they have medicine? Do they understand physics in ways we don't?
And if they could be wiped out so completely that we forgot they existed, how permanent is our civilization? It definitely makes you look at those stones with a little more respect.
Absolutely. It's a reminder that we are small and time is very, very long.
Next time you see a picture of the pyramids, don't just see a tomb, see a clock. And maybe a warning. Thanks for going on this deep dive with us. Keep asking questions and we'll catch you in the next one.